The length of the intercepts made by the circle x squared plus y squared plus 2gx plus 2fy plus c equals to 0, with the x-axis and the y-axis are given by 2 times square root of g squared minus c. So this is going to be the x-intercept, and 2 times square root of f squared minus c is going to be the y-intercept. Okay, so here we have the x-axis and the y-axis, and we can clearly observe here that the circle intercepts with both the x-axis and the y-axis. So let's say the circle intersects the x-axis at 2 points, point A and point B, and it intersects the y-axis at 2 points, point C and point D. Now AB, the length AB is going to be the x-intercept of the circle, and CD is going to be the y-intercept. So our goal will be to find out the intercept of the circle, the x-intercept and the y-intercept. So we'll begin the problem by first finding out the x-intercept. And once we find out the x-intercept, we'll generalize the idea to find out the y-intercept as well. So we'll start with our given equation. So we have the general equation of the circle, which is x squared plus y squared plus 2gx plus 2 times fy plus c equals to 0. Since we are finding out the x-intercept, so here the y value must be equals to 0. And that's evident because at point A and point B, we have no y values, or we can simply say that along the x-axis, we'll get the x-intercept where the y value is always 0. So that means our equation will now become, so this is equation number 1. So equation number 1 follows that we get x squared plus 2gx plus c equals to 0. Now, we have already assumed that point A and point B is going to lie on the x-axis. This is the point where the circle cuts off the x-axis. In other words, we can say that the x-coordinate of point A and the x-coordinate of point B, these 2 points are going to be the roots of the given equation. So let's define the coordinates of point A. The coordinates of point A is going to be x1 comma 0, and we'll suppose that coordinates of point B are x2 comma 0. So here we're supposing that x2 is greater than x1, which also means that since we have already mentioned x coordinates of point A and point B are the roots of equation number 2, so we can say this implies that x1 and x2 are the roots of the quadratic equation as given by equation number 2. So if x1 and x2 are the roots of equation number 2, then the sum of the roots x1 plus x2, this is going to be equals to, we have negative 2 times g divided by 1. So all we're doing, we're dividing the coefficient of x by the coefficient of 1, and we're taking the negative value of that. So this will be equals to negative 2g. Fine. And the product of the roots x1 times x2, so that's going to be equals to the constant term c divided by the coefficient of x squared. Since it's 1, so we have c divided by 1 giving us only c. So now we have the sum of the roots as well as the product of the roots. Okay. Now, what about the length? Since we are trying to find out the length of the x-intercept, the length of the x-intercept, so that's nothing but the length AB. So that's the length AB. Now, how do we find out the length AB? So that's nothing but the difference of the x coordinates. So if we do x2 minus x1, that's going to be the length AB. Because from the origin to the point B, the length is x2. And from origin to point A, the length is x1. So if we subtract the portion OA, which is x1, from the portion OB, then that's going to give us the length of the x-intercept. So that's nothing but x2 minus x1. So now we have x2 minus x1, and we have the sum of the roots and the product of the roots. Using these two information, we can find out the length of the x-intercept. So let's do one thing. Let's manipulate this. So here, x2 minus x1 can be also expressed as the square root of x2 minus x1 whole squared. Okay, now we can further simplify this as x2 plus x1 whole squared minus 4 times x1 times x2. So that means if we expand this and simplify it, we are going to get back x2 minus x1 whole squared. Now the reason why we're writing in this particular fashion, because x2 plus x1 whole squared can be replaced with the value negative 2g whole squared minus 4 times the x1 times x2, that's c. We have already obtained this value. So let's simplify this. So we're going to get square root of, so negative 2g whole squared will be 4g squared. 4g squared minus 4c. So we can pull out the 4 because that's a common factor. The square root of 4 will be 2. Now we have 2 times square root of g squared minus c. So this is going to be the length of the x-intercept, which is nothing but AB. Length of the x-intercept. So now we have found out the length of the x-intercept. So using similar logic, we can also find out the length of the y-intercept, which is nothing but y2 minus y1. Now what we'll do, we'll start with the original equation, and this time, since we're trying to find out the y-intercept value, we will let x equals to 0. So we'll get a quadratic equation in y, and in that particular equation, we will suppose that the y coordinates of point C and point D are going to be the roots of the quadratic equation. And once we find out the sum of the roots and product of the roots, we can easily find out the length of the y-intercept as well. So we will get length of the y-intercept. So the y-intercept, which is nothing but the distance CD. So that will be given by 2 times square root of f squared minus c. Now, couple of results that we can immediately think of once we have the length of the x-intercept and the y-intercept. Let's talk about the x-intercept. So we have 2 times square root of g squared minus c. Let's say we get the value of g squared greater than c. What does it mean? So if we get g squared greater than c, this means that the circle is going to cut the x-axis at 2 points. So we are going to get 2 distinct points, and they are going to be real. They're going to be 2 real points. Real in the sense means they are going to cut the x-axis at 2 points, and those 2 points are going to give us real numbers. Then the next condition is, what if g squared comes out to be equals to 0? So if g squared comes out to be equals to 0, that simply tells us that the length of the x-intercept is 0. If the length of the x-intercept is 0, it simply means that the circle is going to simply touch the x-axis. Simply touches the x-axis. Fine. And then we have the third case when g squared is less than c. Now if g squared is less than c, then this particular expression is going to be complex in nature. We can say it is imaginary. If it is imaginary, that simply means that the circle does not touch the x-axis. Or in other words, we can say that it's not going to give us any real values. So the circle does not touch the x-axis at any real points. That's very important. At real points, why I'm mentioning it's a real points, because the circle might still be touching the axis at the imaginary points. So that's why it's only is not going to touch the x-axis at a real point. So these are the 3 conditions that we immediately get, or 3 results that we immediately get based on the value of g squared minus c. This also applies for the y-intercept as well. So similarly, if we get f squared greater than c, then there will be 2 distinct points, and the points are going to be real. That means the circle is definitely going to intersect the y-axis. And next case, if we have f squared equals to c, then the circle is going to only touch the y-axis at a single point. And the last case, if f squared becomes less than 0, this is not 0, it is a mistake. This is not 0, this is c. So if f squared is less than c, then the circle is not going to touch the y-axis at any real points. Let's try to understand the concept with the help of few numerical problems. Problem number 1. Determine the length of the intercepts made by the circle. So we have the equation of the circle here with the coordinate axis. We have the equation of the circle given in the general form. We have x squared plus y squared minus 4x minus 6y minus 5 equals to 0. So we are going to compare it with the general equation of the circle, which is x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. Then we're going to get the values of g, f and c. So here we have 2g equals to negative 4, which implies that the value of g must be equals to negative 2. We have 2 times f, that will be equals to negative 6, so f will be equals to negative 3. And then we have the value of c, so c is given by negative f. Now to find out the length of the x-intercept, the length of the x-intercept, that's given by the formula, we have just found it. This is 2 times square root of g squared minus c. We'll substitute the values. So we have 2 times square root of g squared. So g is negative 2. So squaring it gives us 4. So we have negative 2 squared minus c. So c is negative 5. This is going to give us 2 times square root of 4 plus 5. So 4 plus 5. So 4 plus 5 will be 9. So square root of 9 is 3. So our length of the x-intercept is going to be 6. Okay, and then we are going to find out the length of the y-intercept. So the length of the y-intercept is going to be equals to, so we know it's given by 2 times square root of f squared minus c. So this will be equals to 2 times square root of, so f is negative 3. You have negative 3 squared minus negative 5. This will be equals to 2 times square root of 9 plus 5. So 9 plus 5, that's 14. We have 2 times square root of 14. Fine. So we have obtained the x-intercept as well as the y-intercept. Let's go to the second problem. Problem number 2. A circle has an x-intercept of 8 and touches the y-axis at the distance of negative 3 from the origin. So we need to determine the equation of the circle. Let us begin. So first we are going to consider the general equation of the circle. Now it's given in the problem that the circle has an x-intercept of 8, which means 2 times square root of g squared minus c. This is nothing but the length of the x-intercept, so it's already given that this has a value equals to 8. Let's label this as number 1. We'll come back to this in a moment. And also it's given here that this circle touches the y-axis at a distance of negative 3 from the origin. Now first of all, if the circle only touches the y-axis, so recall, so we had the y-intercept given by 2 times square root of f squared minus c. We have a condition. So if f squared minus c equals to 0, or we can say if c equals to f squared, then this is the case when the circle just touches the y-axis. So we have a condition here, c equals to f squared. Also we can say that the point 0 comma negative 3 lies on the circle. This is the point where the circle touches the y-axis. So it is negative 3 unit on the negative 3 units from the origin, or can simply say 3 units below the origin. Fine. Since this particular points lie on the circle, it has to satisfy the equation of the circle. So that means our equation will become 0 squared plus negative 3 squared plus 2g times 0 plus 2 times f times y plus c equals to 0. So we're going to get 9 minus 6f plus c equals to 0. So this gives us the third equation. Now we will use equation 2 and 3. So what we'll do? Substitute the value of c equals to f squared in equation number 3. So equation number 3 is now going to become, so instead of c we have f squared minus 6f plus 9 equals to 0. So this is what? This is a quadratic equation. So we have f squared minus 2 times f times 3 plus 3 squared equals to 0, which is nothing but f minus 3 whole squared equals to 0. So here we're getting the value of f equals to 3. So 3 is repeating here twice. Now that we have the value of f, we can also find out the value of c. So from equation number 2, so we considered c to be equals to f squared. So that means the value of c will be equals to 3 squared, which is 9. So now we have the value of c as well. We have the value of c, we have the value of f. Our next task will be to find out the value of g. So we'll use the equation 1. So we have 2 times square root of g squared minus c equals to 8. We have from equation number 1, 2 times square root of g squared minus c equals to 8. Or simply square root of g squared minus c equals to 4. We've divided both sides with 2. We'll replace the value of c with 9 to get square root of g squared minus 9 equals to 4. Let's get rid of the square root by squaring both sides. So we're going to get g squared minus 9 equals to 16. So g squared is going to be equals to 9 plus 16, that's 25, which means that the value of g comes out to be plus or minus 5. That means it could be positive 5 or negative 5. Now we have all the required values. So g came out as plus or minus 5. The value of f came out as 3 and the value of c is 9. So therefore the equation will be thus the equation will be x squared plus y squared plus 2g. The g will be plus or minus 5x plus 2 times f times y plus c equals to 0, or simply put, let's further simplify it, x squared plus y squared plus or minus 10x plus 6y plus 9 equals to 0 is the required equation of the circle. So here in this case we're going to get two equations of circles. Now both the two circles are going to touch the y-axis at a point 3 units below the origin, but they're going to have two x-intercept. One x-intercept is going to lie along the positive x-axis and the other x-intercept is going to lie along the negative x-axis. Hence that is why g is giving us two values. One is plus 5 and the other is negative 5. Okay, now let's go to the next problem. Problem number 3. Here we need to verify that the circle given by x squared plus y squared minus 2ax minus 2ay plus a squared equals to 0 touches both the coordinate axes. Let us begin. So here what we'll do, we'll consider the general equation of the circle. So we know the general equation is given by x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. So on comparing, then we are going to get 2g equals to negative 2a, which implies that the value of g equals to negative a. Then we have 2 times f, so that will be equals to negative 2a, which gives us the value of f as negative a. And then we have c, so c is equivalent to a squared. Now what is the length of the x-intercept? Now we know that the length of the x-intercept is given by 2 times square root of g squared minus c. So let's substitute the values here. So we have 2 times square root of, so g is negative a. So we have negative a whole squared minus a squared. So that's going to be nothing but 2 times square root of a squared minus a squared. So we get the value is 0. So since we are getting 0, this simply tells us that g square must be equals to c, which means that it is touching the x-axis. Similarly, we can find out the length of the y-intercept. So that's going to be equals to 2 times square root of f squared minus c. So if we substitute the value of f with negative a, so we can negative a squared minus c. So c value is a squared, and this is also giving us a value 0. This tells us that f square must be equals to c, meaning the circle is touching the y-axis as well. So we have verified that the circle given by this particular equation touches both the coordinate axis. Problem number 4. Determine the equation of a circle that passes through the points 1, 2 and 3, 0 and cuts off an x-intercept of 4 units. So what we'll do, we'll begin the problem by first considering the general equation of a circle. Now it's given here that the circle passes through the point 1, 2, which means that this particular point is going to satisfy the equation of the circle. So we should get 1 squared plus 2 squared. All we are doing is replacing the value of x with 1 and y with 2. Is 2 times g times the x coordinate, that's 1, plus 2 times f times the y coordinate value, that's 2, plus c equals to 0. So that's going to give us 1 plus 4 plus 2g plus 4f plus c equals to 0. Simply put, we have 2g plus 4f plus c equals to negative 5. We're going to label this as equation number 1. Now also the same circle passes through the point 3, 0. So that means our equation is going to now become 3 squared plus, so y will be 0, 2 times 3 times x plus c equals to 0. Or simply put, we have 6x plus c plus 9 equals to, this is g actually. We have replaced the value of g with 3. So 6g plus c plus 9 equals to 0. So let this be equation number 2. And also we are given the x-intercept value. The x-intercept which is given by 2 times square root of g squared minus c. So this is equals to 4 units. Meaning we have g squared square root of g squared minus c equals to 2. Squaring both sides gives us g squared minus c equals to 4. Or we can say c will be equals to g squared minus 4. Let this be equation number 3. Now what we'll do, we'll substitute the value of c with g squared minus 4 in equation number 2. So equation number 2 is now going to become, we have 6g plus c, but instead of c, we're going to replace it with g squared minus 4 plus 9 equals to 0. That gives us g squared plus 6g plus 5 equals to 0. Now we have a quadratic equation in g. We can easily factorize this. We're going to get g plus 5 times g plus 1 equals to 0. So we get two values for g. So g could be -1 or it could be -5. Now that we have the value of g, we can also find out the value of c. So from equation number 3, we have c equals to -1 squared minus 4. So this is when we are considering g equals to -1. So that will be 1 minus 4. So c comes out to be -3. And c will be equals to -5 squared minus 4. This is when we consider g to be equals to -5. So we have 25 minus 4. So that's going to be 21. Fine. Now let's find out the value of f. Go back to equation number 1. So now we have the c value, c value equals to -3, g value equals to -1. Then the corresponding f value is going to be, we have 2 times -1 plus 4 times f plus c. So c is -3 equals to -5. So let's solve to get the value of f. So we have -2 plus 4f minus 3 equals to -5. So we have 4f minus 5 equals to -5, which gives us f value equals to 0. So we have g equals to -1, f equals to 0, and c value equals to -3. Okay, next what we'll do, we'll again use equation number 1, and we will be using c value equals to 21, g equals to -5. Then equation number 1 will give us 2 times g, so g is -5, plus 4 times f plus c, so c value is 21, and that's equals to -5. Then we get -10 plus 4f plus 21 equals to -5. So we have 4f, so 21 minus 10, that's going to be +11 equals to -5. So 4f comes out to be equals to -16, so f value will be -4. So now we have g value equals to -5, f equals to -4, and c value equals to 21. So using this 3 values, we can define the equation of the circle. So we get x squared plus y squared. We need 2gx. So 2 times -1 will be -2x. Then f is 0, fine, plus c. So c is -3. So this is going to be one equation. So let's box it. And the equation of the other circle is going to be x squared plus y squared plus 2gx. So we're going to get -10x. Then we have +2fy. So we're going to get -8y plus c. So c value is 21. That's equals to 0. So these are the two equations of the circles. And both of the two circles are going to pass through the given points 1, 2 and 3, 0. And also they are going to have an x-intercept of 4 units. So we'll do one final problem. This is similar to problem number 1. So we need to find out the length of the intercept measured by the circle x squared plus y squared minus 10x plus 6y plus 9 equals to 0. So we're going to compare it with the general equation of the circle. So comparing with the general equation, which is given by x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0, comma, we are going to get 2 times g, so that will be equals to -10, which implies that the g value must be equals to -5. Then 2 times f, that will be equals to 6, so f value will be 3. And then we have the c value, so c corresponds to +9. So now we can easily define the x-intercept, which is given by 2 times square root of g squared minus c. So this will be equals to 2 times square root of -5 squared minus 9. So we get 2 times square root of 25 minus 9. So 25 minus 9, that's 16. So we have 2 times square root of 16. 16 is 4. So we have 2 times 4 equals to 8. So that means the x-intercept is going to be 8 units. Then we are going to find out the y-intercept. We have 2 times square root of f squared minus c. This will be equals to 2 times square root of 3 squared minus 9, which will be equals to 2 times square root of 9 minus 9. Then we get a value 0. Now, this particular condition indicates that the given circle is going to touch the y-axis. However, it is going to intersect the x-axis at 2 points, and the length of those 2 points is going to be 8, which is nothing but the x-intercept value. So this is how we deal with problems involving intercepts of a circle along the axis.